Hi, welcome to this Corbettmaths video on sequences. In this video we're going to look at a level 2 further maths topic called limiting values. So here we've got a sequence and the first term is 10, the second term is 12, the third term is 14 and the fourth term is 16. And if we were asked to work out the nth term for the sequence, well, because it's getting bigger by 2 each time, we would write 2n, and 2n would be 2, 4, 6, 8, and each time we're adding 8, so the nth term for the sequence would be 2n plus 8. Now sometimes we're asked to find out what happens as the value for n gets bigger and bigger and bigger, and n's the term number. So we've got the first, second, third and fourth term. So what happens as we look at the 10th term or the 20th term or the 100th term and so on? And obviously for the 100th term it would be 2 times 100, which is 200, plus 8 would be 208. If we want to know what would happen at the 1000th term, it would be 2 times 1000, 2000 plus 8 would be 2008. Now sometimes in a question you'd be asked what would happen as n tends to infinity. In other words, what happens as the term number gets bigger and bigger and bigger and goes off to infinity. Now, as you know from looking at the sequence, the answers at the terms get larger too. There's 2 times n plus 8. So if we put in a million, it would be 2,000,008. So what would happen in this sequence is 2n plus 8 would go off to infinity. As the sequence carried on, it would just go off to infinity. This is called a divergent sequence. Because it diverges, it just goes off. Now, in some sequences, they converge, they get closer and closer to a certain value or a limiting value. So let's have a look at one now. So here we've got the sequence, 9 quarters, 18 fifths, 27 sixths, 36 sevenths. Now let's work out the nth term for the sequence. Well, for the numerator, as you can see, it's the 9 times table, so that's going to be 9n. And for the denominator, well, each term's getting bigger by 1 each time, so it's going to be 1, 2, 3, 4. But we're adding 3, adding 3, adding 3, adding 3. So the nth term for the denominator will be n plus 3. Now we may want to know what happens as the sequence carries on and carries on and carries on. Now I'm just going to change these numbers to decimal numbers. Now if we have a look at these as decimal numbers, 9 divided by 4 is 2.25, 18 divided by 5 is 3.6, 27 divided by 6 is 4.5, 36 divided by 7 is 5.143 rounded. As you can see, they're getting the numbers are getting closer and closer to a particular value. And if you carry this on and work out what would be the 5th term and the 6th term and 7th term and so on, they'll get closer to a certain value. So let's have a look and see what happens as n tends to infinity. So what happens to the sequence as the value of n gets larger and larger and larger. So what I'm going to do is I'm just going to work out what the 10th term would be. So the 10th term, or n equals 10. So if n equals 10, we would get 10 times 9, or 9 times 10 would be 90, divided by 13. And if we done that, 90 divided by 13, we would get 90 divided by 13 is equal to 6.923 to 3 decimal places. If we had n is equal to 100, we would have 9 times 100, 900, divided by 103. And if we work that out in the calculator, 900 divided by 103, our answer would be 8.738 to 3 decimal places. If n was equal to 10,000, so choose a much larger number here, we would get 90,000 divided by 10,003. And if we done that, we would get 90,000 divided by 10,003, and the answer is 8.997. Now looking at these answers, I can see that as n tends to infinity, our answer will get closer and closer and closer and closer to 9. And the reason is, if we put in a very large number, perhaps a million, 9 times a million divided by 1,000,003, well, the 3 doesn't actually have much of an effect on our answer. It means that our answer is really, really, really close to, not quite 9, but just under 9. If we put in a billion, it would be 9 billion divided by 1,000,003. That plus 3 has such a little effect, we can almost just ignore it. And we could say, well, 9n divided by n, well, the n's would cancel, so this would tend to 9n over n plus 3. Because the plus 3 has a very little effect, 9n divided by n would get closer and closer to 9. And this is called the limiting value. 9 would be the limiting value. Okay, let's have a look at 2 questions now. So our first question. The nth term of a sequence is 4n minus 1 divided by 5n plus 8. Write down the limiting value of the sequence as n tends to infinity. So as we had like very large terms in the sequence, maybe the millionth term or the billionth term, what will they get closer and closer to? Well, the minus 1 and the plus 8 will have a very little effect. So we would have we'd be left with, if for instance the millionth term, well, it'd be 4 million take away 1, and this would be 5 million plus 8. Well, they're going to have a very little effect, so the answer will get closer and closer and closer to 4n over 5n. The n's would cancel, so it would get closer and closer to 4/5. So the limiting value for this sequence as n tends to infinity would be 4/5. Okay, let's have a look at our last example now. So our last example says the nth term of a sequence is 3 subtract 7n over 2n plus 6. Write down the limiting value of the sequence as n tends to infinity. So as we generate the sequence, as we get very large numbers of n, so very large term numbers, perhaps the millionth again, we'd have 3 subtract 7 million divided by 2 million plus 6. Well, the 3 and the 6 will have a very little effect, so we'll be left with minus 7n over 2n. Now again, the n's cancel, so we'll be left with minus 7 over 2. So this sequence, as you put in large numbers, you can test it out in your calculator and put in the 1000th term and the 10,000th term and see what you get. But they're going to get closer and closer and closer to this limiting value, which is minus 7 over 2, or minus 3.5. And that's it.